and he also provided many students for training with us. So already got placed.
Okay.
Who really lives in India, but having a great experience, an excellent trainer. Okay.
Yeah. Hi, Neeraj. How are you?
I'm good. What about you?
Doing fine.
Okay, that's good. So I think we can start with a quick introduction of yours, and then I will introduce myself. So can you just tell me brief about you, like which technology you are working upon, and uh, how much of experience you have?
Yeah, sure. So I have around 6.5 years of experience. Before I used to work for Infosys in India, I was in SAP and Java.
Okay.
Actually, had training in Java, then got placed on Java project, and then worked on SAP PI. Then I did my master's from here in computer science, and I'm working as a business systems analyst here with one of the companies. And yeah, during my computer science, I master's in computer science, I did a lot of projects on Java, Oracle, and etc. All the computer science technologies, like usually databases, Java, C, C++, and currently I'm working on SAP WM and looking to move on to more on Java side.
Okay, that's good. Okay, so let me introduce myself. My name is Neeraj, and I'm working in the IT industry from last 15 years. From last 5 years, I'm working on Hadoop, HBase, Hive, Pig, Scoop, all that.
Okay.
And before all this technology, because these are new and emerging technology, before this technology, I was also working on Java.
Okay.
Okay. And I'm associated with the I2c Business Solution from last 4 or 5 years. We are sharing the knowledge. I'm sharing my big data and Hadoop knowledge with the working professionals like you in India as well as with US folks. So that's all. Along with, I'm currently also working on big data and all other Hadoop related technology. And along with that, I spare some time, and we also conduct this online training.
Okay. Okay. Sounds good.
Okay. So I think we can start with the demo now. I would like to make it as interactive as possible.
Okay.
That means whenever you have any doubts, or it's not only about doubts, maybe you want to say something, you want to add something, so feel free to do that.
Okay. Yeah.
So you can see my screen, right?
Yes.
Okay, that's good. So let's start the demo. That is, welcome to Big Data. This would be giving you the brief introduction what Big Data and Hadoop is all about. Agenda is the internet in real time. What is Hadoop? Master a slave architecture. Hadoop distributed file system, which is also known as HDFS. MapReduce. Hadoop Services. What is big data? Why Hadoop is important for career. Prerequisites to learn Hadoop. And last but not the least is Hadoop training details.
Okay.
So this is the agenda, and we'll be covering each and every point in much more detail in upcoming slides. So let's start with the first one, that is internet in real time. Nowadays, every single device, whether it's your smartphone, your Android phone, and your tablets, laptop, desktop, even televisions, are nowadays connected to internet. And from early morning to late night, we are doing a lot of stuff over internet. We are watching movies, we are uploading videos on YouTube, we are searching something on Google, we are purchasing products from eBay, Amazon, Snapdeal, Flipkart, and we are doing online transactions. And last but not the least, social networking. We all are part of Facebook, LinkedIn, Twitter, WhatsApp. So morning till evening, we are doing a lot of stuff. And every activity we perform on internet, that is ultimately increasing the data. So the current slide, which you can see right now, at the bottom, there is a link given, right? If I will click on that link, a page will be opening in the web browser that shows the real-time uses of internet. I mean, currently how much of activities are happening on internet. So these stats are actually keep on changing, because as the time will go like 5 seconds, 10, 15, so it will keep on changing.
Right.
So just for our explanation purpose, what I have done is I have taken a screenshot of that, as you can see now.
Okay.
Okay. So that we can discuss about that, because if the stats will keep on changing, it would be a little difficult for explanation. Okay.
Yeah.
So you can see at the bottom of this screenshot, it is written that, by the way, in the 5 seconds you have been on this page, approximately 1,12,870 GB of data was transferred over the internet.
Yeah.
Quite surprising, right? Just in 5 seconds, 1,12,870 GB of data.
Yeah.
And this is only for 5 seconds. If I will talk about the data generated in 1 hour or 1 day or last 5 years, it would be quite huge amount of data, right?
Right.
And the details are displayed here. If you want to see more detail, you can see in these 5 seconds, 55 new accounts are created and 28,500 new tweets are there on Twitter. This is the stats only for 5 seconds. In YouTube, 11,570 video hours are uploaded, watched, and 10 video hours are uploaded.
Right.
Similarly, we have stats for LinkedIn, we have stats for Skype, Google, there's many searches, this much of revenue. We have Amazon, there's many items purchased, this much of revenue generated. App Store, there's many applications downloaded and installed. Play Store, Facebook, there's many likes, there's many posts, 30 GB of data was transferred over the internet. And WhatsApp, 60 new accounts are created and these millions of messages are sent just in 5 seconds.
Yeah.
So the point here is that if 5 seconds can generate this much of data over internet, and if someone will say that I want to analyze last 5 years of data, so data would too much to be handled by a single system.
Right.
Right. I cannot expect a single machine to deal with the last 5 years of internet data, because if in 5 seconds this much of data can be generated, so gone are the days when we were dealing in MB and GB of data. In current scenario and in upcoming days, upcoming years, we have to deal with terabytes, petabytes, and even zettabytes of data. Okay. So this slide was just I can say just to give you a reference how much of data is being generated over internet every day. Okay, so moving to the next slide, like what is Hadoop? As we have seen on the previous slide, that data is too large to be handled by a single system, and the traditional technology, Microsoft SQL Server or Informatica or Teradata or Oracle, these are not capable of dealing with the terabytes and petabytes of data.
Right.
That's why nowadays in new technology, emerging technology, and the red hot technology, Hadoop is there in the market. That is Hadoop. So we'll try to understand what Hadoop is all about. So first of all, Hadoop is an Apache product.
Right.
Apache is the company which is developing Hadoop, and this is open source framework. That means anyone can go to Apache website, you can download it and you can use it. There is no cost associated. There is nothing you need to pay. Okay.
Yeah.
Another point is this is a distributed storage and this is a distributed processing environment. It seems like there are some technical stuff, distributed storage, distributed processing. We all are technical guys. You and me both are technical. We can technically explore anything. Right. But my funda is, let's start with a layman language so that even a layman person and a simple person can understand what Hadoop is all about. Forget about technology. Technology we'll be exploring shortly. Now let me give you a small, very simple example. Suppose there is a school and in that school there is a principal and suppose there are 10 teachers as well. Now there's a task. The task is checking 1,000 answer sheets of the students.
Right.
Principal may be qualified enough to do that activity. But the point is, if a single person will do that big task, he or she will be taking a lot of time. Right. Instead of that, we have another option. We can distribute the task among 10 teachers.
Right.
That means one teacher can check 100 answer sheet, and that's not a big task. He can do that. Okay. And this is not a new concept. This is a very old mathematical concept. More number of workers will be taking lesser time to complete the job, and the vice versa.
Right. Right.
Same funda applies to Hadoop. When you have terabytes and petabytes of data, don't overload a single system. Don't expect that the single system will do something for you. Instead of that, if I have multiple machines, suppose I have a lab and which has 50 machines. So I can distribute my storage among them. That means my big data is suppleted and stored on each machine. So every machine is participating in the storage. You can say distributed storage.
Right.
And same funda applies for processing. When I want to process that, when I want to analyze that large amount of data, because my data is not available on single system, it's available on multiple systems. So every machine can participate. Just like those 1,000 answer sheet were distributed among 10 teachers, and every teacher is checking 100 answer sheets without bothering about others. The same way you can distribute the storage and you can distribute the processing among multiple machines. That is the basic concept of Hadoop. Okay, so with the distributed storage and distributed processing, we can deal with large amount of data very easily. Okay, so till this slide, any doubt or you want to add something?
No doubt as of now. I think you're going good. Yep.
Okay, that's good. So moving to the next slide. The next is master-slave architecture.
Right.
If I talk about again about school example, principal was the controller, because principal was basically distributing the task,
Right.
not actually checking the answers. He was controlling the things, managing the things, and teachers are the actual worker, or you can say actual heroes who are doing the task. Right. The same funda applies to Hadoop. Out of multiple machine, one machine is sorry, one machine is working as master, and one more machine is working as secondary master. You can say, like in school we have vice principal. If principal is absent, there must be someone who can take care of the responsibilities.
Right.
So we have a master machine, we have a secondary master machine, and all other machines are slave machines, as you can see here. Okay, and this complete setup, master, secondary master, and multiple slave, this complete setup is known as Hadoop cluster. Okay, so the very basic question when you go for an interview, they may be asking like, what is the size of your cluster? How many machines are there in your Hadoop cluster? So Hadoop cluster is very common terminology which you will use every day while working in a project. Okay, so one more point you can notice from this picture is that user is talking to only master.
Yes.
He's not directly interacting with slave machines. That means suppose you have a very large file, maybe 10 terabytes of data. So you will be requesting the master machine that I want to store this data, and how should I do that? So master machine will be splitting that big data into smaller parts and ultimately storing it on multiple machines.
Right.
The same funda applies for processing. When you want to analyze something, when you want to execute some job, then you will be again requesting the master that I want to execute this job, and then it's master machine duty to distribute that job among multiple slave machine and get the things done. The point here is the user need not to interact with the slave machines directly.
Right.
Okay, so that is master slave architecture. Let's move to the next slide. Okay, the next is Hadoop distributed file system. Quite lengthy name, and in short you can call it as HDFS.
Yeah.
So in our previous slide we were talking about two things. One is distributed storage and another is distributed processing. So this HDFS is about the storage part of Hadoop. You can say distributed storage.
Right.
Okay, in this picture there are multiple boxes. Let me first of all tell you, till now we were using very generic term like master machine and slave machine.
Right.
Okay. Anyone can understand that master slave is very common terminology, but in Hadoop terminology, master machine is actually known as name node. As you can see in this picture, the central box, this one is name node, which is actually master machine. We have a backup node, which is actually the secondary master machine.
Right.
And all the data nodes are nothing but the slave machines. So these are Hadoop terminology: name node, backup node, and data nodes. Okay. And this dotted arrow indicates that name node is giving instruction to all the data nodes. You can say master is controlling all the slaves.
Right.
Okay. So this is master slave architecture. And if I talk about these colorful blocks, these are 3 and 5, 15. These 15 blocks are nothing but part of a big file. The file was too big that it cannot be stored on a single machine. And user has requested master machine that I want to store this. So master machine will be splitting that file into multiple smaller parts, and those multiple smaller parts can be stored distributively on multiple machines, as you can see.
Okay.
Now
So
those 15 blocks are stored on 5 machines.
yeah.
So
So
any doubt?
master is responsible for distributing the files on the different data nodes here, and
Yes.
I see that there are different colors like orange, black, and blue are on the first data node, and then the black one is also on the third data node.
Right.
So
That's good.
does that mean that there will be replication of files on two different servers?
Yes. That's the correct statement, and I appreciate your observation. That's correct observation. You can even talk about any blocks. Let's talk about this orange. This is available on first. This is available on second. This is also available in third one. So are we maintaining duplicate copy of data? And if yes, then why? Because that is ultimately wastage of resources, right?
Yeah.
The point is that suppose I have let's again talk about school example. I have 10 teachers and I have distributed the task of checking 1,000 answer sheet, and suddenly 2 teachers are not feeling well.
Right.
So what does that mean? Does that mean like my task will not be completed now? It's not like that, because 8 teachers are still there. 8 teachers are still healthy and they can still complete my task. The only thing is they might take little extra time, because the 1,000 answer sheet which were supposed to be checked by 10 teachers, and somehow the same number of answer sheet now will be checked only by 8 teachers. So they might take little extra time, right? So the same funda applies to Hadoop. When you have 5 machines in a cluster, and suppose one machine is down, and if I'm saying that I cannot complete my job because one machine is down, that is very weird statement, because out of 5 only one machine is down and you are saying that you can't complete your job, right? So but the point is, if the machine is down and if I cannot access my data, so how can I complete the processing? That's the point. So just to avoid this scenario, because this is a very weird scenario, out of maybe let me talk about Yahoo has a Hadoop cluster of 4,000 machines.
Okay.
So out of 4,000, if only one machine is down and I'm saying that I cannot complete the job, that's not a good thing, right? So you must do something so that even few machines are down, you must be in a position to complete your job.
Right.
And that is, processing is not an issue. Any other machine can process the data, but the point is the data is available on some system and the system is down, you can't access your data. That's the point. So just to avoid that scenario, Hadoop internally maintains duplicate copy of data. And how many copy it maintains, that is completely in our control. While installing Hadoop, I can decide like how many copies it should maintain. 2 copies, 5 copies, 10 copies, I can decide that.
Okay.
By default, it maintains 3 copies. So in that case, suppose you submitted a job and processing started, and suddenly something wrong happened, power failure, virus attack, hard disk crashed, something happened, and your 2 machines are down. So now job will not be failed, because master machine is smart enough to detect that particular machine is not responding. And another thing is, before rescheduling, master machine should know like where exactly the same copy is available, right? Because processing can be done by any machine, but you should get the same data. So master machine, as being the master, as being the controller, has the complete information that okay, 9th and 10th machines are down, that's fine. I have the duplicate copy of data available on 4th and 5th machine, which are perfectly up and running.
Right.
So now your job will be rescheduled automatically on alternate machine. And the interesting part is, user is not aware about this.
Right.
You submitted a job and forget about this. Internally, whatever is happening, any machine is down and rescheduling is happening, that all controlled by a name node.
Right.
Ultimately, at the end, you will be getting your output without knowing whether 10 machines participated in that or whether only 8 machines participated in that. You are not bothered about that because you got your output. But again, if you say that I want to know whether 10 machines participated in my job or something wrong happened in between and how many machines participated, then we have the way to find out all that stuff. But otherwise, user is responsible for executing the job, triggering the job, and finally you will get the output. Whatever in between is happening will be completely controlled by master machine.
Okay.
Does that make some sense?
Yes.
Okay, that's good. So this is about storage part. I think you should have a brief idea about storage part now.
Yeah.
Okay. So any doubts?
No, I think I asked in between only the
Okay.
doubt that I had.
Okay, that's good. So moving to the next part, that is MapReduce.
Yeah.
So in simple terminology, I was saying distributed processing.
Mm-hmm.
And in Hadoop terminology, it is known as MapReduce.
Okay.
Ultimately, MapReduce is nothing but a technique to process your data parallelly on multiple machines.
Okay.
So first of all, MapReduce plays a key role, an important role in Hadoop framework.
Mm-hmm.
So why MapReduce is playing an important role and why the storage was not playing the important role? Because storage nowadays is not a big deal. You can attach a portable hard disk, you have Google Drive, you have Dropbox. There are so many nowadays cloud services available which you can avail for storing your data distributively on multiple machines. Okay, so storage is definitely not a big deal, but processing is required because the main purpose is processing. Main purpose is analyzing your data. You are opening Facebook, and on the right side of this, you can see different type of advertisements. This can be for mobile phone. This can be for some sale going on Amazon. This can be for some online training. This can be for some gaming website or anything else. And depending upon your preference, depending upon your age group, depending upon your hobbies, you may be clicking on some advertisement. So whenever you are clicking on some advertisement, Facebook is capturing that detail because they want to analyze that people from which age group, people from which gender, people from which educational background, people from which geographical location are interested in which type of products.
Mm-hmm.
So that they can make their advertisement more effective. Okay, if some singer is there and singer is logging into Facebook and Facebook is displaying the advertisement, do you want to learn Hadoop?
Mm-hmm.
Definitely the singer will not learn Hadoop, right?
Right.
So this is very irrelevant ad, and displaying the correct ad, displaying the attractive ad is possible only if you have analyzed the complete scenario. Maybe in last 5 years you have analyzed a lot of history, and now you have very good idea that if someone is logging in from California and his age group is 25 to 35, he is from this particular background, then from your history you can analyze that if I will display this advertisement, that may be attractive for you. Right. So the purpose of analysis, it's not only about Facebook, but analysis can be of anything: transactional data, eBay, Snapdeal, trending on Twitter or Facebook advertisement or anything else. So Hadoop is basically processing the large amount of data to do some analytics, and the purpose of analytics is business.
Mm.
If you have the right stats, if you have the right business decision stats available with you, you can say make your business more effective. You can increase your business in the right direction.
Right.
Okay. So anyway, let's talk about MapReduce. Is a programming model for writing applications that rapidly process large amount of data.
Right.
In simple words, I can say that MapReduce is the processing part of Hadoop, the job part of Hadoop, and the, you can say, specialty is that it can be executed on multiple machines.
Okay.
You are from Java background, so I can tell you, like, if you are writing a simple Java program that can be executed on a single system.
Yes.
It does not have capability to run parallelly on multiple machines. So MapReduce program is basically, I would say, a special type of Java program which has a extra feature that it can be executed parallelly on multiple machines.
Okay.
Okay. So now MapReduce, as you can see, consists of two words: map and reduce. And in order to understand these two, or these are also known as a mapper and reducer. So in order to understand this, I will take you back to the school example to make it quite simple to understand, and then we will come back to Hadoop.
Okay.
Okay. So let me remind you, principal distributed the task of checking 1,000 answer sheet among 10 teachers, right?
Right.
That means one teacher is responsible for checking only 100 answer sheet.
Right.
And he is not bothered what other teachers are doing.
Right.
Because he has got his 100 answer sheet, he's checking that, he will be preparing the result for those 100 students, and that's all. But now there is a small challenge. Principal will come and principal may say that I have distributed the task among all of you. That's fine. But that does not mean that you 10 guys will be giving me 10 different results. I still want one consolidated result for my school.
Right.
But we don't have consolidated result. We have 10 teachers and every teacher has small results. Now what principal will do? Principal will choose one teacher that can you please collect all that result from all the 10 teachers and consolidate that into a single result, and that single consolidated result, can you please give it to me? That's what I need.
Right.
Okay. So now the individual activity, every teacher was checking 100 answer sheet without bothering about other teachers. That particular activity, that particular processing is known as mapper.
Okay.
And the last activity, one teacher was collecting the small result from each teacher and consolidating that into a single unit and handing over to the principal. That activity is reducer.
Okay. Yeah.
That is just for your quick understanding for in the school example context. Let me come back to Hadoop now. You submitted a job to master. You will request master machine that I want to execute this job.
Yes.
Okay. Then master machine will distribute your task among 10 machines, and every machine is independently processing the data.
Right.
That independent processing every machine is doing is mapper.
Okay.
And at the end, you know what will happen? Master machine will choose one machine, one slave machine, basically, that you have to do the consolidation part. So that particular machine, first of all, fetching the intermediate result from all the machines. Okay. Why I'm saying intermediate? Because that's not final output, right?
Right.
That needs to be consolidated to make it final result. That's why I am saying intermediate. So one machine will be fetching intermediate result from all the machine, consolidating that into a single result and handing over to master machine. That activity, that processing is known as reducer.
Okay. Yeah.
Okay. I think that explanation is sufficient to understand, but still if you want some definition type thing, it's there on the slide.
Yeah, that's fine.
Mapper processes input data parallelly on multiple machines to generate intermediate output data.
Yeah.
And reducer is fetching intermediate output data from all the mappers, or you can say all the machines, and generating final output data.
Yeah. Yeah.
Okay. So this is about the processing part of Hadoop, which is known as MapReduce.
Okay. Yeah.
So any doubt?
No.
Okay, that's great. Okay. So let's move to the next slide. The next slide is Hadoop Services.
Yeah.
When we install any software, maybe apart from Hadoop, if you are installing something on your system, there are a few services running behind that.
Yes.
Similarly, if I will install Hadoop on my system, there will be few services running on my system.
Yeah.
And what are those services? What are their purpose? Let's try to understand. The two services are name node and data node. Few slides back, I was saying that master machine is known as name node and slave machines are known as data nodes.
Yes.
Right? But now I'm saying something different. Now I'm saying that name node and data node are the services.
Okay.
So basically, which one is true? It is a service or the master machine is known as name node. So the point is, yes, tell me, go ahead.
What I think is like they are like services or the processes that are running on machines. So, but we have designated one machine as master machine, basically.
Yes, you are absolutely right. The name node is nothing but a service, but because it's running on master machine, so we usually call master machine as name node.
Okay. Yeah.
Okay. So there is don't get confused with that. Similarly, data node is a service which is running on every slave, and that's why every slave is also known as data node.
Yeah.
Okay. And these two services are responsible for storage part of your Hadoop.
Right.
We were talking about distributed storage, right?
Yes.
So these two services are taking care of distributed storage part of Hadoop, with a small difference that name node is running on master machine and a data node service is running on every slave machine. Similarly, we have two more services, job tracker and task tracker.
Okay.
So job tracker is running on master machine and task tracker is running on every slave machine. And job tracker and task tracker are taking care of the processing part of Hadoop, with a small difference that job tracker is running on master machine and task tracker is running on every slave machine. That's the only difference.
Okay.
Okay, these four services I have even designed in a graphical way so that it's more clear.
Okay.
You can see that we have a central box, the master machine, you can see, On master machine, two master services are running. One is name node and another one is job tracker. So name node is taking care of storage part, and the job tracker is taking care of your processing part. Okay. Similarly, data node and task tracker services are running on every slave machine.
Yes.
So and apart from master and slave, we have a secondary name node as well. That's the backup of my master. Okay. So in simple words, I can say that name node, along with all the data nodes, is taking care of your storage part.
Okay.
And job tracker, along with all the task tracker, is taking care of your processing part.
Okay.
Okay. So any doubt till this slide?
Just one question, like what is the difference between like a job tracker and a task tracker? Like, so and let me so job tracker is just tracking on which machine what data is going, and task tracker is tracking on suppose for a particular data node that this has come, like.
Okay, let me explain.
Okay.
First of all, as far as storage is concerned, there is no role of job tracker, because storage part is taken care by name node and data node. So basically, suppose you want to store big files, suppose 2 terabytes of data, you will be requesting the name node that I want to store this 2 terabytes of data. Right. After that, it's name node duty to assign the task among multiple data nodes.
Okay.
Similarly, when you are talking about processing, you want to execute a job, you will be submitting the job to job tracker.
Okay.
Because that's a master machine. And then master machine task, you can say job tracker will be assigning the task to multiple task tracker, and multiple slave machines will be processing your data.
Okay.
In simple words, I can make one more statement here, that master machine is neither participating in storage nor participating in the processing.
Okay.
It's only controlling the things, managing the things. It's not storing, it's not processing. Name node is giving instruction to data nodes to store the data. So data will be stored by data nodes.
Yeah.
Similarly, when you are requesting the job tracker that I want to execute this job, so job tracker will be assigning the task to the task trackers, and task trackers are ultimately processing your data.
Okay. Okay.
So these are different services running on master, secondary master, and slave machines. Any doubt till this slide? You can ask me.
No, I think I asked already. Yeah.
Okay, that's good. So moving to the next slide. What is big data? Very important thing. Nowadays, you might be hearing from your friends that someone is saying that I'm working on Hadoop.
Yeah.
And the next day he may be saying he's working on big data.
Yeah.
Similarly, if you will go to any website, you will find an advertisement, learn Hadoop. Then on another website, you will find learn big data.
Yeah.
So then the point is, are these two things same, or they are interchangeable? The answer is no, they are not same. They are similar. What are the differences? We will be talking now.
Okay.
So big data is a story of 3 V's. And what are those 3 V's? First V is volume. On the very first slide, we talked about that 1,11,000 and a few hundreds of GB of data was transferred, right?
Yeah.
So
yeah.
volume of data is quite high. And velocity, that 1 lakh of data, GB of data was transferred in just 5 seconds. So velocity of data is quite high.
Right.
And if I talk about the third V, that is variety. Variety is again very high, because we have audio data, video data, transactional data, social networking data, e-commerce website, banking transactional, and so many things. We are opening Facebook, we are playing games, we are changing our status, we are uploading, you can say, audios, videos, images, and so many other stuff.
Yeah.
So we have different variety of data. So if I combine all these 3 V's, that is volume, velocity, and variety, the data complexity is very high.
Yeah.
And to deal with this much of complex data, Hadoop is not sufficient, because Hadoop is a base technology. So it can provide the base. And on top of base, we have few sub technologies like HBase, Hive, Pig, Scoop, and there are so many others. So now the point is, what's the difference between Hadoop and big data? Hadoop is just Hadoop, and big data is Hadoop plus all these sub technology.
Okay.
So I can say that I'm working on Hadoop, HBase, Hive, Pig, Scoop, or in simple words, I can simply say I'm working on big data.
Yeah.
So big data is Hadoop plus sub technologies. So they are not exactly same, but almost same, because out of all the technology, Hadoop is the base and Hadoop is the most important one. All other sub technology like HBase, Hive and all that, these are ultimately dependent upon Hadoop only. If Hadoop is not there, there is no existence of the sub technologies. Okay. So this is like what is big data.
Yeah.
You want to add something here or any doubts?
So I think, the big data is Hadoop plus all the technologies. And I think Hive and Pig are just basically for analysis. And HBase might be the database for the big data, for the Hadoop.
Absolutely right. You must have heard the terminology NoSQL.
Yes.
No, HBase is NoSQL.
Okay, HBase is NoSQL. And what is a Scoop? Like a Scoop, is it just for analysis, or what does it do?
Okay, Scoop is not a analysis tool. Scoop is import and export tool.
Okay.
Just like ice cream scoop. He's putting ice cream from ice cream box and putting into the plates, right? So Scoop is a tool which is used to import and export the data. Suppose your current project is running in Oracle, and now every company is jumping into Hadoop and big data. So maybe your company will say that, okay, let's jump into big data. So you can jump, that's fine. You can install Hadoop, that's also fine. But the challenge is that your current data is available in Oracle.
Yeah.
So you need to migrate your data from Oracle to Hadoop. And for that, we need the tool Scoop.
Okay.
Okay, so Scoop is import and export tool. You can do the vice versa also. You have some data in Hadoop and you want that data back into Oracle, we can even do that.
So basically, Scoop might work between the HBase and my Oracle. So it's like conversion of data from structured to non-structured or non-structured to structured.
Conversion is not the right term. I would rather say import and export.
Okay.
You are importing the data from Oracle to HBase and you are exporting the data back, maybe from Hadoop to Oracle or Hive to Oracle and something like that. And this is part of our training program. We will be covering this practically in our 1 month training program.
Okay. Okay.
How to install it, how to use it, and everything practical.
Okay.
Okay. So I think let's move to the next slide. The next is why Hadoop is important for career. We are talking a lot of things about Hadoop, right? And people are, you can say nowadays, every single company, small, medium, big companies are jumping into Hadoop. So definitely there must be something attractive in Hadoop. That's why it's important for career.
Yeah.
So the very first and important thing is better salary. That's true. Because if you will compare the billing rate of a Hadoop consultant with the other technologies guys, you will definitely getting the higher salary.
Okay.
Another point is big companies are hiring. Sometimes new technology is coming and we are not confident whether this technology will be famous or not, whether companies will be using this technology or not. If I will learn this technology, whether this would be good for my career or not. There are so many questions in our mind, right?
Yeah.
But these questions does not make any sense for Hadoop because every single medium or big companies are involved in that. I was talking about Facebook. Facebook is a partnership with Apache for a sub technology that is Hive.
Yeah.
Because Facebook is extensively using Hive for its business intelligence. Similarly, I was talking about Yahoo also. Yahoo had set up a Hadoop cluster of 4,000 machines. And what they are doing, they are analyzing the mails, whether this is a genuine mail or this is a spam mail.
Okay.
Ultimately, they are analyzing something, right? Analysis can be on transactional data or social networking or anything, whatever you want.
Yeah.
Okay. So basically, very big companies are involved in that, and the future is definitely bright without even 1% of chances of, you can say that it won't be famous.
Okay. Yeah.
Okay. So very big companies are involved in that, and all the big companies which have a large amount of data like Amazon and you can say Walmart and eBay, Snapdeal, and all the banks, they are already working on Hadoop and all its related technologies.
Okay.
Okay. The next is globally available. If I talk about social networking or online banking, online transactional, Google, YouTube, it's available worldwide. That's why even the opportunities for Hadoop are worldwide available.
Yeah.
Okay. And finally, better job opportunity. If you are switching your career from any other technology to Hadoop, or if you are starting your career in Hadoop, that's definitely a good decision in this particular scenario in which Hadoop is the red hot topic.
Yeah. Okay.
Okay. So these are a few points just for your quick reference, like why Hadoop is important for career. And moving to the next slide, prerequisites to learn Hadoop.
Okay.
So we are, you can say, almost technically done for Hadoop demo. Now, if we are planning to go for this Hadoop training, then what are the things required?
Okay.
Hardware wise, software wise, all that. So let's talk about the first one, Linux based operating system, macOS, Red Hat or Ubuntu.
Okay.
Windows cannot be used for Hadoop installation.
Is it? Okay.
Yes, I know that is surprising because Windows is the operating system used worldwide, and every layman person is also using Windows, right? But Hadoop is not made for Windows. You need any Linux based OS, not specific, any Linux based OS that can be Mac OS, Red Hat, CentOS, Fedora or Ubuntu.
Okay.
And in case you don't have any of the operating system, even there is nothing to worry about, because our first class is dedicated for Linux based operating system installation on your system.
Okay, so I can have like a virtual machine, VMware or something installed.
Absolutely right. That's I was just about to say that we will not be deleting your Windows.
Okay.
Your Windows will be as it is. You can use it personally. And for our Hadoop training purpose, we will be installing VirtualBox. Inside VirtualBox, we will be installing Ubuntu, which I have highlighted in a different color.
Yeah.
Because Ubuntu, first of all, quite simple to use, just like Windows. Another point is it's free of cost available. It's an open source.
Okay.
So we can download Ubuntu, we can install Ubuntu, and this is not more than half an hour activity.
Okay. Yeah.
Half an hour, one-time activity.
Yeah. Yeah.
Okay, so we can achieve that. That's not a big deal.
Yeah.
Second is Java 1.6 or higher version.
Yep. Okay.
We are not talking about Java knowledge here.
Yeah.
Java programming knowledge, you know or don't know, that does not matter. The point is we need Java software. So that is also free of cost available. We can download it from internet and we can install it within 5-10 minutes, not more than that.
Yeah.
Okay. Next is disk space is required to hold a large amount of data, that different parts of the your data and even the duplicate copies of data.
Yeah.
So we need some hard drive and we also need some RAM for processing of data.
Okay.
But it is needless to say that someone is having a laptop or desktop, definitely the system will be having hard drive and RAM, right?
Yeah.
So that's not an issue. And we don't have any specific requirement. That's the point. You have 100 GB of storage, you have 1 GB of RAM, 2 GB of RAM, or i5 or i3. Does not make any sense. Whatever system you have, that's good for Hadoop.
Okay.
From Hadoop side, there is no specification that you must have this configuration. It is not there. The reason being is that Hadoop is not concentrating on the computing power of a single system. It's not concentrating. It is concentrating on number of machines. So if you are facing some issue or you are saying that my data is quite large, then increase the number of machines. Okay. So a group of computers is required. And in one of the slide, let me go back. In one of the slide, we were talking about, yes, one is master, one is secondary master, and 5 are the slave machines.
Yeah.
So for learning purpose, do we need 7 systems? No.
We can
That's
have
not
processes. Yeah.
Sorry?
We can have multiple processes running on systems.
Okay. Let me rephrase your statement.
Right.
We can use the same system for master as well as slave.
Okay.
Logically, your machine can work as master and your machine can work as slave.
Okay.
Suppose you are sending one SMS from your mobile number to your mobile number.
Yeah.
So you are the sender and you are the receiver. So similarly, your own single system can work as master as well as slave, and logically it's possible.
Okay.
Okay. So you can see that all the master services, all the slave services will be running on your system only.
Okay.
Because your system will be working as master as well as slave.
Okay.
So for learning purpose, Hadoop can be installed on single system. To conclude this, I can say there is no cost associated with software because it's free of cost available. You can go to Apache website, download it and use it. And as far as hardware is concerned, there is no cost associated. Whatever laptop or PC or desktop you have, that can be used for Hadoop installation. Okay. So we are done with the introduction to Hadoop. In case you are having any doubt, you can ask me.
No, I think I asked in between. Yeah.
Okay. So I hope that you have a brief idea what Hadoop is all about.
Yeah. Yeah.
Okay. So we are done with technical introduction, but we are still left with one slide.
Yeah.
That is Hadoop training details. So
Yeah.
I can show you the training details. There are two type of Hadoop training. One is Hadoop developer training, which needs prior Java knowledge.
Okay.
And it is suitable for the guys who are coming from Java background.
Okay.
And this is very less famous because if I talk about complete IT, you can say technologies, people are from DBA background and you can say warehousing background and informatica and business intelligence and testing background and so many other backgrounds, right? Java is one of them. So the more famous and more common training is Hadoop admin training.
Okay.
Because that does not need Java knowledge. That's one thing. And it's suitable for the guys coming from database, data warehousing, informatica, mainframe, and business intelligence background.
Okay.
Now, which training I will be conducting? So I will be conducting a complete package that is Hadoop admin plus Hadoop developer plus HBase, Hive, Pig, Scoop, and a POC, proof of concept, a mini project you can say.
Okay.
So this is the, you can say, agenda, you can say, which we will be covering in our 1 month training program.
Okay.
The classes are usually, you can say, 5 days a week, Monday to Friday India time. That is Sunday to Thursday evening US time.
Okay. So Sunday to Thursday, what timings?
Timings, it all depends. Multiple batches are going on. Currently, I think one batch is going at 9:30 p.m. Eastern time.
9:30 p.m. Eastern. Okay. And usually the classes are like 1 hour long or 2 hour long?
It's 1 hour every day.
1 hour every day. Okay.
On average, it's 1 hour, but sometimes if you have some doubt or you are facing some issue, so that class may go beyond 1 hour, 10 minutes or 15 minutes, but average time is 1 hour.
Okay. So,
because in case you are facing an issue, we even have the option to remotely control your system and fix your issues.
Okay. And so a class is going on. So basically, if I want to join, then I can join from tomorrow itself. That is the Sunday class. And
absolutely.
Okay.
Absolutely right.
And how far ahead is that class? Like I don't want to join in middle of the class. And
okay. So what we can do is we have just connected two classes for that. That is Hadoop installation and sorry, not Hadoop installation, Ubuntu installation.
Okay.
Okay. And this demo. So demo you have already attended.
Yes.
So only you can say Ubuntu installation class and one more class you have left. I have recording of every class available with me.
Okay.
Whatever I'm speaking, whatever I'm showing on the screen, that is recorded into a video, and I can provide those videos to you.
Okay.
Those two videos you can watch. You have still 1 day. You can watch that video, and then you can meet me tomorrow.
Okay.
Okay. And any doubt you have, you can ask me in tomorrow's class. In case you face any issue, I can remotely control your system and I can fix that. So be assured that you will be getting full support from our side, and the classes will be fully practical, provided that you need to spend 1 hour every day for attending the training, and you need 1 more hour for doing all these things practically on your system after the class.
Okay. And
not during the class.
Okay. And the classes are like, and the training program will be for 1 month, and we'll be doing some practical assignments also in between.
No, every day. It's every day.
Every day. Okay. Okay.
Every day, whatever things I will explain, and I will execute some commands or jobs or anything, the same thing you have to do on your system after the class.
Okay. Okay. Sounds good. Okay. So is there a detailed course that you will be covering? Like, I know you'll be covering the Hadoop developer plus admin.
Right. I have the complete, I got a point. I have detailed course content, the complete PDF, which we can share with you. You can go through that so that you have the brief idea what different topics we will be covering in this 1 month.
Yeah, that will be great if you can share with me the detailed program.
We can provide you 2 things shortly. One is the meeting link for tomorrow's class. That would be different from this link. And another thing is I can provide you the detailed course content. Okay. And once you will give the confirmation that you want to join this training program, we can even share those 2 classes which you have missed.
Okay. Okay.
Okay.
That sounds
After
good.
that, tomorrow onwards, you can start.
Sure. Thank you.
Okay.
Yeah.
Okay. Any other doubts? Technical, non-technical, anything?
No, I think you have covered most of the things, and thanks for the demo, Neeraj. That's
Okay.
it.
You are welcome, and thanks for making it interactive.
Sure.
Yeah.
Sure. Yeah. Have a great day.
Okay.
It's Sunday in India. Yeah.
Yes, right. Yeah.
Thank you so
Good
much.
night for you.
Chris. Thanks for your time.
Yeah. Okay.
Thanks, Amir.
Thank you. Thank you. Bye-bye.
Bye. Bye.